All right, good morning. I'm Kyle Smith. I'm with Enertech, and I'm the inside sales manager here. And today we'll be going through a webinar, first of two webinar series with Jeff Hammond of GeoFlow. So today's session will be the first of two that I spoke of earlier, and we'll be going over the MP Multi. And so the overview will be pumping applications for large residential, light commercial applications. So then we went over on that on July 13th. So now the next one to follow up on for today that we're doing will be multi-unit application with GeoFlow's MP Multi Flow Center. We'll go over the Flow Center overview, the operation, the options, features, benefits, pumping, etc. And then in our next session, we'll be going over the same thing with the multi-unit applications with GeoFlow's MP Multi-Flow Center, and then continued on August 17th. We'll be going over selecting pumps or zone valves, variable speed central pump system, and then a 5-circuit example. So today, please take notes. If you have any questions, please use the GoToMeeting toolbox there and under questions to type in your questions, and we'll handle those at the end. And if we can, we'll answer them during the presentation. And then lastly, please research and review. Give us a call, use GeoFlow's website, use Enertech's secure site to gather as much information on the MP Multi as you can. And this is a great system, and we absolutely love it. So I'm going to hand it over to Jeff and let him get started.
Good morning. Thank you, Kyle. I appreciate everybody's attendance this morning. As Kyle mentioned, we're going to go over the NP Multi Flow Center. This is a follow-up to our July webinar where we talked about large residential, light commercial applications, and the NP Multi really fits nicely into those type of applications simply because, as you can see from the picture here on the screen, it's everything in one package that's factory assembled. So it does save a lot of time. It's a very efficient way to go, and cost effective from a piping standpoint. So the NP Multi ties right into those large applications, and that's what we'll be focusing on in this webinar. This is the first of two webinars on the NP Multi, so this first one really is more of an overview, and we'll talk about the product itself, options, and so forth. And then the second one, we'll get into detail on pump sizing or variable speed application with zone valves. All right, so this is the product that we're talking about today, the NP Multi. It has two options. The picture shows the Magna 3 variable speed option with zone valves, and as you can see here, the zone valves or motorized ball valves on the right-hand side are attached to this header that returns for the return piping from the heat pumps, and then the supply header has ball valve shutoff. So that's one option. Another option I'll have pictures of later on is the circulator for each zone, or circulators, 1, 2, or 3, instead of this central pump. So the central pump, variable speed with zone valves, is option 1, and multiple pumps is option 2. The variable speed is much more efficient, but it depends on the application and the if it's an existing application, what type of heat pump, and so forth. So in some cases, circulators might be a better option. In most cases, the variable speed Magna 3 is a more cost-effective option just from an operating cost standpoint. All right, so this product is really a flow center. It does include flush valves, and typically we have insulated pumps and we have flow centers. Flow centers have all the parts and pieces, which is what this is. So we call this a flow center mainly because of the flush valves. The flush valves, you can see we have a cam fitting for the connection to your flush cart on the left-hand side. There's another cam at the return header, and there's a cam on the supply header. So those are the connections to the flush cart, and there are ball valves at each of these connections. So it allows us to purge air from the system pretty easily, and that's all factory installed, including the cam. So there isn't anything that has to be changed at the job site. Another very important feature is this pressure vacuum relief cap at the top of the tank, and that allows us to vent at 13 psig, or if the tank is approaching a vacuum, then it allows air into the top. So this the pressure vacuum relief is a very important part of the non-pressurized flow center. All the headers you see are factory assembled, so these are flow link double O-ring connections to the ball valves on the supply header, and the same thing on the return header. They just plug in, and you simply turn the nut to hold that in place. There's also a calculator online. We won't spend a lot of time on that this morning, because that's really part 2 of our webinar, is going through the calculator and sizing a system with the NP Multi. So the tank itself is HDPE polyethylene with saddle fusion connections. You can see here in the picture, this is a sheet metal cabinet and it's foam insulated, but the fittings that stick out of the cabinet, the one here on the left and the one down on the bottom on the right, including the drain valve, those are all saddle fused, so there aren't any mechanical fittings, which makes for a much more robust product. And then primarily because this is a fairly large system, up to about 90 gallons per minute, so we don't want any mechanical fittings in connecting to that HDPE tank. Are all heat fused, so it's a very good way to go for those larger flows. The tank is the same for all the models, whether it's variable speed, whether it's individual pumps, whether it's 1 or 2 pumps on the variable speed, and so forth. So this, what you see here in the tank, is the same for all of the variations of this product. It's a powder coated steel cabinet and foam insulated, just like a flow center, just like a single unit flow center. We do have a sight tube on the left hand side. Because of the height of this flow center, it's a little bit hard to look in through the top of the cap, and so the sight tube will tell you what the water level is, and if we're between the bottom and the top of this sight tube, we know that the water level is appropriate. At the top above the sight tube then will be a pocket of air. So this essentially acts as your expansion tank. As the water temperatures change, the pressures change, and so the water level changes over season. That's your expansion tank, and any air that might be entrained in the system comes back into the top of the tank. So in effect, it's like having an expansion tank and air separator built in by design of this non-pressurized technology. We talked about the pressure vacuum relief. The drain valve at the bottom lets us drain the tank if necessary. And then our connections, you can see here on the left-hand side, we have a 2-inch socket fusion connection, but this could also be a 2-inch PVC glue, or it could be a 3-inch flange. And we typically use the flange connection when we get into higher flow rates. If it's maybe smaller heat pumps, or only 3 or 4 heat pumps, we might be able to use the 2-inch fusion or 2-inch glue. But when we get into 5 heat pumps and higher flow rates, the 3-inch flange works a little bit better. So this is capable of up to 25 or 30 tons, up to 5 heat pumps. And it could also be used for just 2. We've had a couple of applications where we had 2 10-ton water-to-waters, and that worked well, even though it's designed for multiple units. The larger units work well as well. Work well with this flow center as well, and it can save some piping costs. All right, so with the variable speed, we have a choice of 2, 3, 4, or 5 circuits. So these valves, the zone valves and the shutoff valves, are configured based upon that request in the model number, 2, 3, 4, or 5. This one is a 5-circuit configuration here. And we have a choice for zone valves. This shows the Taco Geocentry, which is great, up to about 4 tons. But then larger units, we need to use a CV, a higher CV. So the Belimo valve is typical for, say, a 5-ton unit, or even a 4-ton if we're a little bit tight on pressure drop and we need to lower that pressure drop a little bit. We can go with a higher CV valve like the Belimo. Higher CV equals lower pressure drop, and so we could order this product with the Belimo valve instead of the Taco valve. Finally, if you want to have a remote valve, maybe you want the zone valve at the heat pump, then it could be terminated with just a ball valve instead of a zone valve here, and you can then install the zone valve at the heat pump. With the variable speed option, we have two pumps, the Magna 3 40-120 or the 180. They both look the same like the one here in the picture. It's just a difference of performance. The 180 is the highest head pump. The 120 is a little bit less. So it depends on the calculations that we'll look at in the next webinar with the NP Multi calculator. And then we can configure them as a single pump like the picture, or we can run two pumps in parallel. That gives us the ability to have a full redundancy or partial redundancy depending upon how we size the pumps. And they do talk wirelessly when they're in parallel, so that allows one pump to speed up if the other one fails, for example. We can also look at two smaller pumps instead of one larger pump. The smaller pump, the 120, is a little bit less cost than the 180, and we might not have 100% redundancy, but we could get, let's say, 70 or 80%. So that's always a cost-effective way to go. For higher head applications, we can use two of these in series, and they're mounted one on top of the other. And in that case, now we can have up to almost 100 foot of head with a variable speed central pump system. Now, they don't talk wirelessly when they're in series, but we still do have the capability of having one pump online if one would fail. So we get not 100% redundancy, but some redundancy out of that application. All right, so these are some of the choices that we have with a single pump, which would be the flow rate here on the first line, and the head on the right-hand side on the y-axis, on the vertical axis. But we could also use two pumps in parallel. Now we have double the flow on the second line, or we could use two pumps in series, and that's this M3H column. It's the two pumps in series. So if we wanted to have, let's say, two pumps in parallel, in this example, we could have 60 gallons per minute at about 50 foot of head. The gray shaded area is differential pressure operation. So this is where we would have the zone valves opening and closing and the pump changing RPMs based upon the system pressure. The full curve is only for constant curve or for delta T mode with an external controller. So in most cases, we'll be using this gray shaded area when we're sizing pumps. The calculator, of course, has all that built into it. If we were to look at a high head application or two pumps in series, we might have, let's say, a 10-ton system, 30 gallons per minute. If we follow that up, we can get just slightly under 100 foot of head. Now, that's not typical. That's kind of high for most systems, but maybe it's a retrofit, or we have a very long supply and return lines or something like that. So those are some of the options you have based upon the different configurations. This is what they look like. These are the two pumps in parallel, and again, these talk wirelessly, so if one fails, the other one takes over automatically. And the header or the T's are configured at the factory. So these pumps are mounted on the laminate board you can see here, and then the headers just plug in with the double O-ring style connections. It also ships with Unistrut, so it makes it easy to mount this whole assembly in the mechanical room. If you order two pumps in series, they are connected on this mounting board, as well as the connector in between the two pumps. And so in this case, they have half of the head on one pump and the other half on the second pump. So if we had a system with 60 foot of head, the first pump would be set for 30, and so would the second one. And that gives us the two pumps in series, gives us the higher capability. These are 5-circuit applications. We could have 2, 3, or 4 circuits, and we just simply have less valves and zone valves. All right, these are our zone valve options. I mentioned earlier we have the Taco Geosentry. That's the one that we typically see for up to about 4 tons. And the Belimo valve is a higher CV, lower pressure drop. It is a much more expensive valve. So it's going to be used typically for the largest applications, maybe a 5-ton or 6-ton unit, for example. It's more of a damper type actuator, so that's where the extra cost comes in. And this information is from the submittal in the NP Multi submittal online, and it also shows recommended CV, flow coefficient, which is what's shown here in the specifications for each of these valves, based upon flow rate. So you can see here as the heat pump needs more flow rate, then we need to have a little bit higher CV for that valve. Okay, so this is schematically how this system works. We have a tank. It acts as our expansion tank and air separator, and that also gives us some additional fluid as the season changes and the pressures and temperatures change. So our pump is an integrated variable speed pump. In this case, it says VFD or variable frequency drive, but it's really an ECM motor. That's just a symbol here in the schematic, and then PD is pressure differential or constant pressure. So these two blocks are actually built into the pump. It's an ECM motor pump. It's really not a VFD, but this is typically how it's shown in the schematic. And then each of the heat pumps have a motorized ball valve or zone valve and a shutoff valve on the other side. The thermostat controls the heat pump. When the heat pump compressor is running, it opens the ball valve, motorized ball valve, and the pump sees the change in pressure. So in fact, as this is set up, we would open all of the zone valves and we would set the max head on this pump, and that would give us our maximum flow rate. We would also balance all of these systems. So if we have one heat pump that's quite a ways away, or the heat exchanger is much higher pressure drop, then we can account for that by balancing the system with the zone valves open 100%. Then once it's running, of course, it will change RPMs based upon the number of valves open or closed. So that's schematically how this system works. Obviously, it looks different in the mechanical room, but schematically, this is how it's set up. Now, the other model I mentioned earlier is the version with pumps. So in this case, it's still 2, 3, 4, or 5 circuits, but in the same tank as before. But in this case, instead of having a central pump with zone valves, now we have pumps for each heat pump. In this case, this is not a typical application, but the picture shows some of the capabilities. We have zone 1 with 3 pumps in series, zones 2, 3, 4, and 5 with 2 pumps in series. This is not one I would recommend just because it's an awful lot of watts. Even if it's 2699 Grundfos circulators, they're about 170, 180 watts a piece. If these were 26 116 pumps, they'd be about 280 watts. So it's a lot of watts if you go with individual pumps. Now, if we only had 1 or 2 pumps per circuit, it wouldn't be as bad. But in this configuration is an awful lot. So we can choose the number of pumps. It is built with a ball valve on the before the first pump, and at the last pump there's a ball valve as well as a check valve. So those are factory installed, and just like the previous version, you simply connect the heat pumps to each of these circuits. These would be the supply circuits coming off of the pumps, and the return circuits on the right hand side. Same thing with variable speed. The cam fittings for your flush cart hoses are right here on the end of this header, on the end of this header here, the return header, and also on the other side of the tank, on the left side of the tank. So this still makes for a very quick and easy installation, but it does use pumps instead of variable speed with zone valves. As far as how this operates, each pump circuit, in other words, 1, 2, or 3 pumps, is powered by the heat pump, the load side of the compressor contactor. So when the compressor is energized, those pumps are also energized. And the factory installed check valves prevent short circuiting. So we're not going to have a situation where the water is flowing through the mechanical room rather than out to the ground loop. I won't go through the model numbers, but you can see there are an awful lot of combinations. And so we can choose what type of flow center this is, how many circuits, central or distributed pumping, pump types, zone valves, and so forth. So all that's available in the installation manual and the submittal. Once you get to the point where you're ready to design the system, the NP Multi calculator on the GeoFlow website lets you choose the type of system, variable speed or individual pumps. It lets you choose your zone valves. And then it also, once the pressure drop is calculated and you've selected the pumps, it generates the model number. So it's really a full design package. Now, if you're looking for operating cost, you'd need to go to the pump sizing calculator, which we'll do in the second portion of this webinar on NP Multi. So you can actually compare then operating costs at that point. I just put together a quick 3-circuit example so you can see some of the potential for savings here. This is a 12-ton application with a 3, 4, and 5-ton heat pump. And they're all in the same mechanical room, relatively close together. So we have 2 packaged units and 1 split. In the mechanical room, we have about 100 foot of supply and return lines and 12 vertical bores with propylene glycol antifreeze. So once we did the pressure drop, we selected an NP Multi with a Magna 340-180 based upon our pressure drop calculations. And we could, as I mentioned earlier, add a second pump if we wanted to have redundancy. So that's our example. Like I said, we'll go into this in more detail in the second webinar, but I wanted to at least give you a feel for what our potential savings are. So you can see with this selection, we've reduced the pump watts compared to individual pumps. If all of the heat pumps are running, the variable speed pump is maxed out at 546 watts. So that's if it's running full out, in this case 36 gallons per minute. If only one 3-ton heat pump is running, it's about 27 watts. So it's very, very little energy use with that one 3-ton heat pump running. It only needs 9 gallons per minute. So our pressure drop is very, very low at 9 gallons a minute. If the 4-ton unit were running at 12 gallons a minute, it would be similar, maybe 35 or 40 watts. 5-ton unit, same thing. So as we start adding 2 units or 3 units, or in the case of larger jobs, 4 and 5 units, we might get to the higher watts. But in most cases, it's going to be using about the same as one Grundfos UP 2699. So the average watts is 214 watts. And if we compare that to little individual circulators, just one of the 2699s is 180 watts. So the average is about the same as one little circulator running. Now, in the case of the NP Multi, where we have these various pumps in parallel, if we chose to go with individual pumps instead of a central pump with zone valves, we would most likely need on this job 3 2-pump flow centers, 1 2-pump flow center for each heat pump. And so in that case, if one unit is running, it's 360 watts versus 27 or 40 or what have you, depending upon which unit is running. So significantly more watts with the pumps. If we went with the 26-116, which we have to do in some cases when we're pumping in parallel, then we only have the head of that one set of pumps, even though we might have 5 sets of them. They only have the head of one set. But our watts are significantly higher, so we want to try to avoid this 26-116 if possible. It's about an extra 100 watts. So if we had 3 2-pump systems here, 3 stacks of 2 pumps in series, it would be 3 times the watts of the central Magna 3 pump. So there's quite a lot of opportunity there for savings. All right, let's take a look at how these actually operate. We looked at the schematic earlier. Let's look at the flow paths. When this is piped up in your mechanical room, the from loop is coming into the left-hand side, going into the tank. The pump draws from the bottom of the tank and then delivers flow to each of the heat pumps. From the heat pumps, the zone valves turn on and off based upon which heat pump is running, or if all are running, then all of the zone valves are open. So it's a fairly simple piping and flow path, and then from the heat pumps, it goes right back to the ground loop. So going out to the ground loop, back into the tank, and out through these headers. So it's pretty simple piping arrangement. We do like to see the largest heat pump, or the heat pump with the largest flow, on circuit 1, simply because if we were to divert the most flow through this first circuit, it reduces the pressure drop through these other circuits, through the header, in fact. So we want to have the largest heat pump here on circuit 1, and the next largest on circuit 2, and so forth. And these valves are shipped with the double O-ring connections, so they're all union connections, and they can be moved around on this header. So if for some reason it needs to change a little bit, maybe there's a Belimo valve on the first one and Takeo on the other ones, they can be switched around as necessary. If we're using individual pumps, it's the same setup for the loop connections. It comes in from the loop on the left, goes out to the loop on the top. The flow is just slightly different inside the setup here. So we're coming into the tank, going out of the bottom of the tank, and through each one of these circuits out to the heat pumps, from the heat pumps back into the header on the right-hand side and out to the loop. And the same thing, we want to have the most pumps in series on the first circuit, the next on the next circuit, and so forth, again, so we can reduce pressure drop as much as possible on this header. It just makes the system run better. Flushing is pretty nice with this setup because of the cam fittings and the ball valves that are already built into the system. I like to call it a mechanical room in a box, essentially. So everything is built at the factory. You can see here I have a flush cart hose on the left-hand side and also at the bottom of the return header. So in this case, I'm just going to simply flush the outside portion of the loop. Once I have all the air out of that portion of it, then I'm ready to fill the tank. I won't go through all the details. This is all lined out in the installation manual, but it will let us fill the tank with these same connections. And then I'm ready to flush the inside portion. So now I change my valves again, and I hook up the flush cart to the two headers. This lets me flush each individual circuit. So I'm going to valve off everything but the first heat pump, then valve everything off except for the second, and so on. And now I'm able to flush the air from the ground loop, from the inside piping, and fill the tank as well. If I had a circulator system where I had circulators per heat pump, it's the same setup for flushing the ground loop. I connect my hoses to the return header and the left side of the tank and purge air from the system. And then I fill the tank. Once the tank is filled, I connect the flush cart then to flush the individual circuits for the inside piping. All right, so that's about all the time we have for this webinar. We try to keep these at about half an hour, but I do have time for questions. Let me look and see what we have so far. Okay. We'll wait just a few minutes to see if we have any questions pop up. If you want to type that in to the question section, then we'll address each of those as they come in. Okay, the first question I see is if we have two pumps in parallel and one fails, how does the other pump know how to react? And the answer to that question is the two pumps in parallel are connected wirelessly. So when we set up the system, we tell the pumps that we have one main pump and one second pump. They can be set up either in primary backup or alternating mode or in cascade mode. Cascade mode, they both ramp up and ramp down. So if one pump fails, then since they're already talking wirelessly, the pump that's left knows that there's a problem and it will ramp up to compensate. Now there's also a closed contact that's available that you can connect to a light, a horn, the thermostat, fault light, whatever, that will tell you if there is a fault, and it will display that on the screen. So good question. Okay, here's another question that came in. Okay, using your flow center, how far up in vertical lift can it accommodate? Let's say a 3 to 4 story home. Yeah, this is a non-pressurized system, so we do have to be a little bit careful on height. It is a pressurized system, but because of the pressure relief, it's about 13 psi. So that means we really want to limit the height above the flow center to around 30 feet. And we're usually okay with a 3-story home. A 4-story home might be a bit of a problem. And in that case, what we would probably do is look at a pressurized system. That Magna 3 pump is certainly available as an insulated pump. It's just not quite as handy as the NP Multi, because the NP Multi with the tank and the pressure vacuum relief and all the headers is everything you need in one package. So If we were to do this with a pressurized system and a Magna 3 insulated pump, we'd want to add an expansion tank, and depending on the size, possibly an air separator as well. So the height is a bit of an issue. About 30, 32 feet or so is what we want to make sure that we limit above the flow center. All right, what is the size of the tank, height and width? I don't have that in front of me directly, but it's about 5 feet, more or less, height, and the width is only, if I remember, it's around 14 or 16 inches. So it is a little bit tall, simply because of the amount of fluid that we're running through the tank. It's a 6-inch HDPE tank, and then it's in an insulated cabinet, so it's around, I think it is around 10 or 12 inches now that I think about it. About 5 foot tall. So on a basement with a low ceiling, we do have to be a little bit cautious of that. Okay, we'll wait here for some additional questions. Appreciate the questions so far.
Hey Jeff, I've got one. I know a couple of guys around here that do a lot of the WS unit, which is a single speed water to water. In this case, what kind of pumping selection would we be looking to use if we used multiple single speed units?
It wouldn't really change much with multiple single speed units, because we would still have a choice of either a pump or pumps per heat pump, or we could still use the central pump, variable speed pump with zone valves. So it's an advantage even with a single speed unit, simply because we have the ability to change flow based upon how many heat pumps are calling. So let's say we have 3 single speed heat pumps. We can still have the flow needed for only the one heat pump, the flow needed for both heat pumps, or all 3. So it's really a matter of economics on this type of a system. It's still going to be much less operating costs with the variable speed central pump and zone valves, but it's more upfront cost than individual pumps for those heat pumps. Okay, I don't see any other questions unless you have any others, Kyle.
Nope, I'm good. I think we've used our time today, and thank you for your time, Jeff. We really appreciate it.
All right, thank you, and I appreciate everybody's attendance. You know how to. Oops, we do have one more question. Sorry, we just about closed up too soon here. How do you set up the pump to maintain flow rate? I'm glad I caught that. Good question. When we're setting up the system initially, what we do is we open all of the zone valves and we set the max head on that variable speed pump. And so at that point, we're balancing each of the heat pumps to make sure they have the proper flow. And then once that's done, the system takes over automatically. So it's going to look for how many zone valves are open based upon the pressure setting of the system. And so then if only one heat pump is calling, or 2, then it sees the pressures change and it knows to speed up or slow down the pump. Good question. All right, well, thanks again. You know how to get a hold of Enertech. They have a great inside sales support department, and they're happy to help out with whatever applications you might have. Thank you very much.